Hi, sir. Good evening.
Okay, so just wait for 1 minute, then we'll start. Somewhere in the meantime, just go through the concepts again, the revision from the previous class.
Yes,
Let me check with the others in the meantime. By the way, Somin, which can you tell me which book are you referring to for mathematics, IB, in your school?
so like in the school, our teacher keeps on taking like questions and concepts from many different books and then puts it in a PPT to teach us. So
Okay, so there
there's
is
no
no
one
one.
book.
Okay,
But yeah, this book which you are using, this Hazer and Harris, that one I think she uses the most.
okay. Okay, good evening, Sheldon. Sheldon, am I audible?
Yes, sir.
Okay, great. So just 1 more minute. Let me just see if Vaibhav is joining. Then we'll start. In the meantime, Sheldon, please go through the concepts, especially the dot
Yes, sir.
product from the previous class.
Yes, sir.
All right, just anyways, let's start. Vaibhav will take some time. Okay, so Sheldon, we'll start with you. So I'll just go through the very basics of what we did in the previous class. So starting off with the dot product. So Sheldon, all you need to do is just recall how do we multiply the two vectors using a dot. So let's say if you have a vector which is represented by this, let's say 2, 3, 1. This is the notation, column vector notation. And there is another one which is 1, 4, and let's say 3. Now, Sheldon, do you remember what will be the result if I take the dot product of these two vectors? And how do we do that?
I think the dot product of this would be wait. You had given us actually a formula, if I remember correctly. It was
Yes.
a upon 2.
No, no.
No,
So
no,
see,
no.
let me tell you again. So all you need to do is first focus on the x components, which is 2 and 1 in this
Yeah,
case, right? So just multiply these two, 2 and 1. What you will get is 2, right?
yeah.
Similarly, multiply the respective y components. Tell me what will you get,
You get 12,
and then the multiply the z components to get 3.
3. Yep.
Right? Then all you need to do is just add whatever you have found out. So 2 plus 12 plus 3. So that will give me 17. 17 is the dot product. That is the answer. See, whenever I say a dot product, this is also called the scalar product. Now, the reason why it has this name is after the dot product or the scalar product, the result which you're going to get is nothing but a regular number, which is nothing but a scalar, right? So that's the principle. So you have to remember this, Sheldon, right?
Yes, sir.
Similarly, now in vector product, what happens is we multiply the two vectors, but in this case, just a second. In the meantime, I'm just checking a few things. In the meantime, Samuel and Sheldon, please switch on your videos.
Yes, sir. 1 second.
Just checking some things. Done. Okay, so yes, Sheldon, your video is still off.
Yeah, so just 1 second. I'm just switching on the webcam.
Okay, great, thanks. Okay, so vector product. So where were we? So vector product is basically again multiplication, but the result of that multiplication will be a vector, and that is why it has the name vector product. Now, since it is the result is going to be a vector, so it will have a magnitude as well as a direction, because that's the definition of vectors, right? So let me take a general vector first. Let's say if I have a vector A, B, C. This is one of the vectors. So this is the column vector notation. Now we can also represent that as AI plus BJ plus CK. Both of these mean the same thing. And on the other hand, we have this vector PQR. Now, if we need to multiply these two vectors using a cross, the result, let me just write down the expression and then I'll tell you how to remember this. So for the x component of the result, I will write BR minus CQ. And then for the y component, we will write PC minus AR. And for the z component, we have AQ minus BP. Now, Samuel, by any chance, do you know the method of how to remember this?
Like I don't know it, but a trend that I can see is that like B and R and C and Q, they're like cross multiplied.
Yes, good. So let me just tell you the method. So what you need to do is, if we are finding the x component, so just ignore the x components of the original vector. So ignore that and then consider the y and z components. Now we have to just cross multiply. So we multiply b with r and then c with q and then subtract it. But the order is important. We start with b. So br minus cq. That will give me the x component. Now, if I want the y component of the result, so in this case, the step remains the same. Step one is to ignore all the y components of the original two vectors and focus on the x and z components. So, but in the y case, the direction of the cross multiplication is a little different. So what we do is the p is multiplied with c, and then a is multiplied with r. So PC minus AR, that will be the Y component. And at the end, we have the Z component. For that, let me just draw it again. Otherwise, it will become messy. So ABC and PQR. Now for the Z component, see X and Y are done. For the Z component, ignore all the Z components of the original two vectors and then cross multiply the X and Y components. So we start with A. So A into Q minus B into P. So that will be the Z component, right? So before we go into the questions, I want you to write down this formula and just remember, how do we draw this? How do we find the resultant?
Yes, done.
Great.
So I'll need 2 minutes to write.
Yeah, sure. Take your time. And Sheldon, always remember this cross multiplication thing. So because after this, we'll be solving questions.
Oh, that's all. So basically, for the y-axis, we change the directions. That's all, right?
Yes, that's it.
Okay. Yeah. Got it.
Done, sir.
Okay, great. So now both of you, based on this concept, now let's try to solve the question. All you need to do is just find out the cross product. But there are two parts to this question, so do it carefully.
Done, sir.
Okay, tell me your answer.
Yes, sir. For part A, I got 8, 2, minus 4.
Okay, and for the part B,
Part B, 16, 2, and 4.
so 22.
Oh, we need to add that as well.
Yes, that is the dot product.
Okay, sir.
Okay, good. So someone correct answer. Sheldon, did you get it?
I'm getting how to do it, just taking some time for me, that's all.
So did you solve the first part, B cross C?
I just got the x-axis value, and that's 8. I'm just
What is
putting it.
that? Did you get 8?
Yes, I got it to be 8.
And the rest of the components should be also easy.
Yeah, so it's just taking some time for me, that's all. I'll just
Okay,
try to do the AM. Or
so
should I just go with the B part?
let me just do it on the screen. We can just
Yeah.
check. So 2, 1, minus 1. Oh no, so we are doing
Also,
B
one
cross
small
C.
question.
Yes, Samuel.
So, like writing it as 16, 2, and 4, that is the resultant vector, but we also need to add it to get the exact dot product, right?
Absolutely. So that is, if I scroll up, so on the right hand side, you can see we have added up all the numbers, isn't it?
Yeah.
So that is what we need to do to find the eventual dot product.
Okay. Yeah. Understood, sir.
Because the dot product is nothing but a number. So eventually you should get a number as the dot product, right? Okay, so Sheldon, A part is the cross product B cross C. So starting off with the X component, as I said, ignore the X components and we look at the other components. So 2 into 4 minus 3 into 2 into 4 minus 3 into 0, which is 8 minus 0, which will give you 8 as the X component. Now for the Y component, the 3 needs to be multiplied with 2. So 3 into 2 will give you 6 and negative of 4 into 1. So 1 into 4. 6 minus 4 gives you 2. And at the end for the Z component, ignore the Z component. So 2 multiplied by 2, which will give you 4. Or rather, sorry, 1 into 0. We start from this. 1 into 0, it is 0. Minus 2 into 2, which is 4. So you should get this value 8, 2, and minus 4. Sheldon, just check if this makes sense to you.
Yes, I got the same value.
Perfect. Now, for the second part, which is A dot B cross C. See, B cross C you have already identified. So let me just write that down. Your B cross C is A 2, 8, 2, minus 4. But we have to do A dot this cross product. So what is A in this case? This is 2 1 and minus 1. So we have two vectors. A is this and your B cross C is this. Just a second, Baba has joined. Smera is there. Hello, Smera. Good evening, Smera. Good evening. Okay, Baba, good evening.
Yes, sir. Good evening.
Okay, so let me just finish this. Let me then I'll revise the concepts for you, Baba and Smera. So, Sheldon, for the dot product, all we need to do is now just multiply the respective components. So we take the x components, 2 into 8, which will give us 16. Then we take the y components and multiply them. So 1 into 2 will give you 2. And then minus 1 into minus 4, which will give you 4. But as I said, you need to add all of this to get the results. 16 plus 2 is 18. 18 plus 4 gives you 22. And that is the answer for the part B of this question, 22. So Sheldon, just go through this, check if there is any doubt, or is it clear?
Yes, that's clear.
Good. So please write this down. All right. Okay. Smera, am I audible to you?
Yes, sir.
Okay, perfect. So, all right. So let's start off. So for Smera, you and Babel, I'm just recalling the stuff which we have done so far. In the meantime, Smera, please, both of you, Smera and Babel, please switch on your videos.
Yes, sir.
What I have actually done so far here is initially we had the dot product in the previous class. So in this case, we are doing the cross product. So let's say if you have, let me take regular numbers, so that will be easier for you to understand. So let's say 1, 2, 3. This is one of the vectors, let's say A, and you have another vector 3, 2, 1. Let's take easy example. So these are two vectors. Now we are multiplying them using the cross product. So the concept is the cross product when the result of this will be a vector. See, this cross product is also called the vector product. The reason being the result is a vector, which means it is going to have a magnitude as well as a direction. Now let's focus on the entire vector. So if we are multiplying these two using a cross, so the vector itself will have three components, right? So let's see how to do that. So for the x component of resultant, what we do is ignore the x components of the original two vectors and then focus on the y and z components. So we will have to cross multiply. So we will do 2 into 1. So which is 2 into 1 is 2. Then we subtract and then we take the other cross product. So which is 3 into 2, which will give us 6. So then eventually the x component of this will give you -4. Similarly, if you have to find the y components, let me write down the vectors again, 1, 2, 3, and then 3 to 1. Now for the y component, what we need to do is the step one is ignore the y components of the original two vectors and consider the x and z components. But in this cross multiplication, the direction will reverse. So we start from 3 into 3. So 3 into 3 will give you 9. Then we subtract and then we take the other cross, which is 1 into 1, which will give you 1. So 9 minus 1 comes out as 8. And that will be the y component of the resultant or the vector product. Similarly, for the z component, let me write down the vectors again. So 1, 2, 3, and 3, 2, 1. Now for the z component, all we need to do is ignore the z components of the original two vectors and consider the x and y components. So the cross will go like this. So 1 into 2 is 2. Then we subtract and then we write 2 into 3, which will give you 6. So 2 minus 6 is -4. And that will be the z component of the resultant. So the answer, the vector cross product is -4, 8, and -4. Right now, Smera and Baba, both of you please write this example down, and then let me just tell you a general formula after this. Baba, got the concept? Is there any doubt?
No, sir, no doubt.
Okay. Smera, what about you? Is it clear?
Yes, sir.
And Smera, your video is still off. Just check. And Baba, if possible for you, please switch on your video. Okay, so Baba and Smera, let me know when you finish writing
Yes,
this.
sir. Done writing.
Okay. Baba, what about you?
Yes, sir.
So are you done writing?
No, sir, no, sir.
Okay. And after that, I'll just show you the general formula for this, the vector product. So, Baba, let me know whenever you finish.
Yes, sir. Sir, I'm done.
Great. So all of you please write down the general expression for the vector cross product. So this is the expression which you need to always remember. Either you remember the approach, which we just did, or you remember this formula. It's your wish. Anyways, just for your reference, please write this down. And then after this, we'll be solving a question. All right. Okay, so let me move on. So see, the next concept is, see, what is the significance of a cross product? See, this we had already done in the physics class. So if you remember, A cross B, if how to find the direction in that case, if you remember, we have to visualize a plane which contains both the vectors A as well as B. So let's say if we have two vectors like this A and B. Now, if we have to find A cross B in this case, so all we need to do is first try to visualize a plane which has both of these vectors. So let's say this red plane is that particular plane. Inside this, both A and B exist. Now, if we are doing A cross B, so basically A cross B is a vector which is perpendicular to this plane. So we draw this particular arrow, A cross B. Now this you can solve using the right hand rule. So A cross B is always perpendicular. So either it will go up the plane or down the plane. The point is it is always perpendicular. So that is the significance or importance. A cross B is basically a vector which is perpendicular to both A and B. So let me just elaborate here. So A cross B is perpendicular to B, and A cross B is also perpendicular to A. That's the whole principle behind this. Now, based on this, we'll solve a question. So the question is two vectors will be given to you, A and B, and they will ask, find a vector which is perpendicular to both A and B. So all you need to do is just find out the cross product. So let's see how to do this question. So this is that question. Please write this and try to identify the concerned vector.
Yeah, sir. Done.
Okay, so just hang on a bit, let others solve. In the meantime, Vaibhav, just tell me your answer. Check.
So there's only one vector, right?
So that's the catch. There will be actually. Okay, so what do you think, Vaibhav? This is a tricky concept. Will
Okay,
there
no.
be one vector or will there be multiple vectors?
There'll be two vectors, right?
If you think about it, yes. So rather, if you think about it, there will be infinite vectors.
Oh,
Just think on that concept. How is it infinite? So the point is, whatever A cross B you get, that will be of a particular magnitude. So you can always multiply that vector with a scalar. So you can double it, triple it, make it 4 times, multiply that by -3. You can do whatever it is. So
okay.
that's why
So,
infinite
so
vectors.
will it be plus or minus k for
Yes,
the entire
perfect.
vector?
So whatever you get A cross B, so just multiply plus minus k with it. Or rather just k. K is anyways a scalar. It can take both positive and negative values. So Vaibhav, can you tell me the A cross B which you got?
Yes, I got -6, 2, and -2.
-6, 2, and -2.
Yeah.
Okay, that is correct. Samuel, Sheldon, please check what A cross B you're getting.
Yeah, so basically we have to use the vector scalar product and
Hmm.
just multiply that by any constant, right?
But yes, that is true. But what A cross B you are getting?
I'm getting it to be -6, 2, and -2.
Okay, that is correct. Samuel, are you getting these values?
Yes, sir.
So -6, 2, and -2. So let me just write it down. -6, 2, and -2. Now, basically, what we can also do is we can simplify this further. So we can divide, let's say, what is that one number which can simplify all this, or rather, by which number we should divide. So if I divide all these numbers with a 2, so I'll get -3, 1, and -1. So basically, the vector is 2 times -3, 1, and -1. Right? So if the answer to this question will be, so we have to find all the vectors which are perpendicular to both A and B. So in this case, the fundamental vector which you should consider is this 3, 1, -3, 1, or -1. Even if you take -6, 2, -2, even that is fine. But generally in the books, they take the fundamental value. So -3, 1, and -1. And then all we need to do is just multiply this vector by a scalar. So that will give you the answer. So see, in the question itself, the keyword is all. To find all the vectors. So K will incorporate all possible values of the cross product. Right, and that's the concept behind this A cross B. Sheldon, your video is actually frozen. Can you switch it on and off again?
Yeah, so I think I'll have to rejoin for this one concept.
Okay, in the meantime, let me just go the next question. All right, so Samuel, let me know whenever you're done.
Yes, sir.
Perfect. Moving on to the next question. So the same thing which you have to do A cross B, but with a little twist. So the tricky question, try to solve.
So I'm having a doubt in this question.
Yes, tell me.
So do we essentially get a dot product form for all the three vectors by A, B, then B, C, and
No,
then C,
so
A?
see, whenever the word perpendicular is there in the question, so dot product is completely out of the
Yeah,
picture. You will have to focus on the vector product. So just we have to take two vectors and then multiply them using the cross product. But for that, you need those two vectors, right? So how to do that? So for that, let me just draw the diagram. Let me give you a hint. So let's say A is this point, B is this, and C is, let's say, this. So as I said, if we are finding the cross product, so basically the first step is to identify the plane which has all these 3 points. Anyways, the question in the question itself, it is given that the plane is passing through all these points. Now, since we are supposed to find a vector which is perpendicular to this plane, so all we need to find is identify the two vectors which lie inside that plane and then multiply them using the cross product. So how do we do that? Let's start with A. So A is a point and B is also a point. So if I connect A and B, let's say if I represent AB by this arrow, so AB is a vector. Similarly, if I connect A and C, so that will also be another vector AC. Now, if we have to find a vector which is perpendicular, so all we need to do is just take the two concerned vectors AB and AC and multiply them using the cross product. But the key here is how do you find AB and AC from the points, which are given to you. So this concept which we had done in the previous class. Anyways, let me explain. So if I have a point A and a point B, and in vector terms, we have to find out what AB is. So what we can do is AB can be written as B minus A. So you should just remember this. AB is equal to B minus A. In the previous class, we had gone through the derivation. This is straight away coming from the triangle law of vectorization. But for the exams, just remember the method. Similarly, if I have to find AC, that will be just C minus A. Now let me find out the AB first, and similarly, then you can find AC. So B is 3, 1, and 0. So let me write down B in terms of the column vector rotation 3, 1, and 0 minus A is 1, minus 1, and 2. So if I simplify this, we will get, let's see what we get. 3 minus 1 is 2, 1 plus 1 is 2, and then 0 minus 2 is minus 2. So this will be my AB. Similarly, identify what AC is, and then you cross multiply, or rather find the cross product. So solve this and tell me the answer eventually.
So yeah, so A, B we found using the dot product concept, right?
So, Samit, this is not the dot product we are doing here. So we are just subtracting the
Yeah,
two
this is just
vectors.
finding the vector from the
Yes.
coordinates.
In the perpendicular questions, dot product cannot be used. There is no significance of a dot product.
So I had a question.
Yes, Papa.
Could you take two different vectors? Like if
Yes,
it was
absolutely. You can take any two vectors. Doesn't matter.
okay, so it doesn't have to be AB and AC.
Yes,
Right?
exactly. You can take any two vectors.
It's any two vectors where the tail of the vectors meet, right?
Yes, tails should be connected to each other.
And why is that so?
See, generally we take that because see that is the thumb rule which we follow across the entire chapter. The significance of that is when we use the formulas of the dot product and the cross product. So if you remember the basic expression for the cross product, so let's say if I have A dot B, so A dot B is equal to magnitude of A into magnitude of B into into cos theta, right? And if I have A cross B, so that will be mod A into mod B into sine theta. So these are the basic expressions. Now the correct values of these will depend on the correct value of theta. Now see, theta is of two types. Let's say if I have two vectors A and B which are crossing each other like this. So one angle between the two vectors, okay, let me, one angle could be this, which is theta, and another angle could be this, which is 180 minus theta. So out of the two, we consider the acute angle. So that's why this has been taken as a fundamental principle first we need to make sure that the two vectors are connected tail to tail. And even in that case, we have to consider the acute angle. So theta in this case will be the acute angle, because there is one more possibility. If you consider this, let's say B and A. Again, in this case, the vectors are connected to tail, but this particular angle, can you check, is it acute or obtuse?
This is obtuse.
Yes, so what should be the angle in this case?
I think 180 minus theta.
So if I do 180 minus theta, so which means this. So do you think the tails are connected here?
No.
All right, so see, I'll have to go into this principle into much detail when we go into the formula part. So Samuel, can I explain this point in that topic when we will apply this
Yes,
formula?
sir, that's fine.
So just try to identify AC first, and then we'll do AB cross AC. Sheldon, did you get AC?
Not yet, so.
Solve it and tell me what AC is.
I'm getting AC to be yeah, AC to be 2, -3 and 5.
Okay, so let me just check. Solve. See, so C minus A. C is -1, 2, -3, and A is 1, -1, 2. So minus one will give me -2. 2 plus 1 is 3. And -3 minus 2 is -5. So Sheldon, are you getting this? I think
Yes,
you're
sir.
getting the reverse, 2 minus 3, and
Yeah, actually, no idea. I'm getting the
so
reverse.
you have to do C minus A, not A minus.
Yeah, no bad. I'll just do that.
And let me know if anyone has got the answer.
So I got it.
Tell me.
So like what I got was -4, like AB cross AC
Mhm.
is equal to -4, 14, and 10.
Good, that is correct. So can you simplify that? So divide that by 2.
So if I divide that by 2, it will be -2, 7, and 5. So
Yes,
the vector can be in the form of k into -2, 7, and 5.
perfect. That's the answer. So 2, -2, 7, and 5 needs to be multiplied with the k. That will be the answer to this. All the vectors perpendicular to the plane.
So, and can we also take like -2 outside if that
Yes,
is
you
also
can do that as well, because anyways, k is a number. It could be positive or negative, right?
so like if you're writing something on the screen, I can't see it.
No, no, I'm not writing anything on the screen. So let me just write it here. So AB cross AC. So someone eventually you got -4, 14, and 10, right?
Yeah.
Now this is AB cross AC, fine. But if I have to find out the simplest form in from this, so either we can divide this by 2. So we will get -2, 7, and 5. And if I'm dividing this by -2, so I'll get 2, -7, and -5. Both are fine, because eventually you have to present your answer in terms of a k. Let's say if I consider this, so the answer will be k times -2, 7, and 5. But you have to mention that k is a scalar quantity, which means it can take all possible values, positive as well as negative. Even if I take this particular expression, so the answer will be k times 2, -7, -5. It's the same thing, doesn't really matter. Okay, Vaibhav, did you get the answer?
Yes, sir.
Got the same answer?
Yeah.
Okay, and what about you, Smera?
Yes, sir.
Got the answer?
Yes, sir.
Nice. Sheldon, what about you?
Yes, I got it.
Just Sheldon, just check, are you sure you got the exact value?
Actually, no, wait, not exact. Wait one sec.
Okay, see, let me do it again. So AB, let me just write down the whole thing again. So what was AB? AB was 2, 2, and -2. And what was AC again? AC was -2, 3, and -5. So Sheldon, just see what I'm doing here. So if I'm multiplying with the cross product, so first focus on the x component. So ignore the x components in the original two vectors. So we cross multiply the other number. So 2 into -5 will give you -10. Then you place a minus sign. Then this -3 needs to multiply with this 3. So -2 into 3 will give me -6. So this comes out as -10 plus 6, which is -4. Similarly, now if I consider the y component, so ignore the y components of the original two vectors, consider the x and z components. So Sheldon, for the y component, we reverse the direction. So we start with this -2, multiply this with this -2. So -2 into -2 will give you 4. Then we place a negative sign. Then this -2 in AB will be multiplied with -5 over here. So -2 into -5 will give us 10. Or rather, are we doing some mistake? Let me check. So AB was 2, 2, -2, and -2, 3, and -5. So check. So Samuel, you got 14 as the y component, isn't it?
Yes, sir, 14.
So we check -2 into -2 is 4. Okay, this is not minus. This was plus only, right? For AB, it is 2 to -2. Okay, so 2 into, okay, so -2 into -2, yes. So -2 into -2, that is 4. Then you subtract, then 2 multiplied by -5 will give us -10. So the y component will be 4 plus 10, which is 14. Okay, now it's fine. Now for the z component, ignore the z components of the original two vectors. Then we do 2 into 3, which is 6, minus 2 into -2, which is -4. So this will come out as 6 plus 4, which comes out as 10. and this will be the resultant vector product, -4, 14, and 10. So Sheldon, just check and please write this down, the
Yes, sir.
expression. And then, for those of you who are done, let me present another question on the same principle. Let me- Or rather, it's fine. So we'll take up more questions after we do some more concept. Okay, so Sheldon, let me know whenever you're done.
Yes, I'm done right now.
Perfect. So now, if I have to find the magnitude of A cross B, see, so A cross B, the vector product, we have identified what is the method. Let's say A cross B is a vector which in the column notation is PQR, or we write that as PI plus QJ plus RK. So I'm taking a general example. So any two vectors A and B, if I'm multiplying using the cross product, let's say if I get Pi plus Qj plus Rk. So A cross B is basically a vector in a particular direction. If I have to figure out what will be the magnitude of this vector, so basically the length of this line segment will give you the magnitude of this vector. So to find that out, magnitude of A cross B, we represent like this. So magnitude of A cross B will be given by this formula. We write P square plus Q square plus R square. Right? So this is the, please write down this formula. So the magnitude of a cross product. All right, so moving on, another important concept. So if you remember the original coordinate system, the x-axis, the y-axis, and then we have the z-axis. Now, earlier I told you the concept behind the unit vectors. So I basically represents a unit vector which is parallel to the x-axis. So along the x-axis, if I draw a unit vector, that will be I. Similarly, if I draw a unit vector along the y-axis, that will be j. And if I draw a unit vector along the z-axis, that will be denoted by k. So I, j, k basically are just unit vectors. Now, we can also find out the cross product between these. So if I do I cross j, for instance, can you figure out what will be the magnitude of this? What will be the magnitude of I cross j using the,
Root of I square plus J square.
yes, so which is,
Like which will be root 2, right?
so first figure out what will be I cross j. So see I cross j, so this is just a vector product, right? As I told you, the vector product will be perpendicular to both I as well as j, which means the answer to I cross j, it will be either plus k or minus k, right? So now just let me tell you the formula or the method how to do this. So write down the I, j, k like this, and then make a cycle like this. So we are going in the clockwise direction. So if I do I cross j, which means I'm going along the cycle, so that will give me plus k as the answer. Similarly, if I do j cross k, which means again I'm going with the cycle, so the answer will be positive I. At the end, if I have k cross I, which is again going with the cycle, that will be plus j. So this is one set of notations. Similarly, now let's go against the cycle. Let's start with I and we go towards k. So I cross k. So we are going against the cycle. So the result will be j, but with a negative sign. So I cross k will be minus j. Similarly, then if I do k cross j, that will be minus I. And at the end, j cross I will be minus k. So all of these formulas you should remember by heart. So please write this down and the consequent method, the cycle method. So after writing this, please let me know whenever you're done, all of you.
So is there anything to write on the top?
Yes. So
Yeah.
did you not write this? The magnitude
Yeah,
of A
yeah,
cross
I'm
B?
done with that. I'm done with
Okay,
that.
so after this, just write down all of this, the unit vector part, I, J, K.
Yeah, so done. No, almost done.
Okay. And from this, once you're done with this, tell me if you can tell me this value. What will be the magnitude of I cross J? Because this is what I started the topic with. What is the magnitude of I cross J? Let me know when you're done, all of you.
So is the uh, magnitude going to be just one?
Exactly. Good. Now you have understood. Okay, so let me elaborate on that. But before that, Sheldon and Baba, are you done writing?
Yes, sir. Done writing.
Okay, Baba?
Good.
Baba, your audio is not clear. Are you done?
Yes, I've done writing, but I'm still a bit confused.
In which part?
Like when you do I cross J, when you said that it equals K, and then you say I cross
So
K.
see, if you remember the right hand rule, so all we are see the result which you are seeing here, all these six expressions are deriving from the right hand rule. So if I take I as my first vector and J as my second vector, use the right hand rule and see where the thumb is pointing towards. So
Okay.
right,
Okay.
so that way we have derived all these expressions,
Okay. Sir.
right? And then the subsequent question which comes from this is what will be the magnitude of I cross J? See, I cross J is nothing but K. So magnitude of I cross J will be equal to magnitude of K. So K is nothing but a unit vector, and a unit vector has a magnitude of 1. So we write this as 1. So that's why all of the cross products, so either if you have I cross J or J cross K, or let's say anything, let's say K cross J, any type of permutations, the answer will be always 1, right? So that's the whole concept. Please write this down. And please let me know when you're finishing, when you're done writing. Okay, Sheldon, are you done?
Yes, sir.
Samuel, Baba, Smira,
Yes, sir, done.
okay.
Yes, sir.
Smira, by the way, you would definitely need to go through the recording because you're going on and off the class. So I'll be sending you the recording, so please go through that again.
Yes, sir.
Okay. All right. So now please write down the next title from vectors. It's called the geometrical interpretation of A cross B, or rather, what is the physical significance of A cross B? Or rather, the magnitude. It's not just the A cross B. A cross B is a vector which is perpendicular to both A and B. But if I take the magnitude, it has a special significance. So what we do is, let's say if I have a vector A in this direction and B in this particular direction, and we are trying to find A cross B, and then we try to figure out the magnitude of that vector as well. So basically, if I connect or rather make a parallelogram out of this, then the magnitude of A cross B will be equal to the area of this particular parallelogram which you are seeing here. So area of the parallelogram, let me write down the letters. See, let's say PQRS. So this parallelogram PQRS area will be equal to the magnitude of A cross B. And similarly, if I divide this by 2, let's say if I do mod A cross B and we divide that by 2, this is equal to the half of this parallelogram. And what is half of the parallelogram? That would be just the triangle. So this will be equal to area of the triangle PQS, which is also equal to the area of triangle QRS. Right, so this is the geometrical interpretation. Please write down this one. And once you are done with this, I'm going to write a question. Based on this, try to solve this question. Try to solve this question and tell me if anyone gets the approach at least how to solve this. Okay, so Sheldon, are you able to get an approach at least for this question?
Not really, so but I know that we're supposed to get the magnitude for this.
A cross B, right? So we
Yeah.
have to find two such vectors. Right, so this type of a question which we have already done, if you recall, right in this class, so we have 3 points A, B, C, right? So figure out what will be AB, then figure out what will be AC. So that will be your two particular vectors which you need. So we do AB and then AC. So what you need to do is just cross multiply these two vectors, then take its magnitude and then divide that by 2 will give you the answer. This is the approach. So basically you have to first identify what AB is and what AC is. So Sheldon, let's go step by step. So solve and tell me first of all what is AB. See, all you need to do is just AB is just B minus A. So Sheldon, solve this. Tell me what will be AB. Yes, Rahul.
So even I'm done.
Okay. So just a second. So Sheldon, can you tell me what is AB in this case?
Yes, one second.
And Smera, are you done as well?
No, sir, I'm still solving it.
Okay. Did you get the two vectors, AB and AC?
Yes, sir.
Okay.
Yeah, so AB is 4, -1 and 1.
Okay, let me cross check. So B is 2, 1, 4. A is minus 1, 2, 3. So we get 2 plus 1. Sheldon, the x component will be 3. 1 minus 2 is minus 1. 4 minus 3 is 1. So this should be your AB. So
You know
Sheldon,
what? I think I've messed
use
up.
did you
Yeah.
write these particular numbers?
Yeah, so I did.
See 2, it is 2 if I look at the x component. So 2 minus minus 1. So this is written as 2 plus 1, which is nothing but 3. This
Yeah,
is
sorry. So
your
I was just I was using my like I was doing my book. I wasn't using my calculator, and I wrote it to be 2 minus bracket -2. So that's why I got it to be a 4 actually.
okay. So
Yeah,
it's 3 minus 1
yeah.
and 1. So and similarly, you can find AC as well. Okay. So now, Vaibhav, can you tell me your answer first? What did you get?
So I got root 41.
Root 41. Let me just check. And Somil, what's your answer?
So I got root of 270 by 2.
So is the 2 inside the root or outside the root?
Root of 270 whole upon 2.
Okay. So which means it is outside the 2. Vaibhav, just cross check. Your answer is not really correct. So could you repeat your answer, Vaibhav?
So root 41.
No, so the answer is square root of 270 whole divided by 2. Now, even if I simplify this, let's see, what do I get? So 270 by 4. So even if I simplify this, what you should guess is square root of 67.5 and not 41. So Baba, please cross check your calculations. In the meantime, let me just write it down and then all of you can cross check. So AB and then AC, let's find what AC is, which is C minus A. C is 0, 5, minus 1. Negative is minus 1, 2, and 3. Let's see what do we get. 1, 3, and then minus 4. So this is my AC. All we need to do now is do AB cross AC. If we do that, the answer which you should get is 1, 13, and 10. So this should be your final vector product. After this, we find out the magnitude of this particular vector. So if I do mod AB cross AC, so it will be equal to square root of 1 square plus 13 square plus 10 square. So how much is that? 169 plus 1 plus 100. So this will be square root of 270. So this is the magnitude of AB cross AC. Now, since we are supposed to find the area of the triangle, not the parallelogram. So we need to divide this by 2. Which will be the answer? So Baba, please check where did you go wrong in your calculation.
Wait, so what is AB again?
AB is 3 minus 1 and 1.
Yeah, so both my vectors are the same, but I got
Okay.
1, 8, and 10 instead of 1,
Okay,
13.
let me check again. 3 minus 1 and 1. Let's solve. 3 minus 1 and 1. If I do the cross of that with 1, 3 and minus 4, was that the correct value? 1, 3 and minus 4. Yes, so that is AB cross AC. So let's solve this. So for the x component, we do minus 1 into minus 4, which is 4 minus 3. So the x component will be 1. And what will be the y component? It will be 1 into 1, which is 1 minus 12. So this will be 13. And for the b component, we will have 3 into 3, which is 9 minus 1. So this comes out as 10.
Okay,
So it
yeah,
is 1, 13 and 10, Baba.
yeah. So I just made a calculation.
Okay, so maybe a sign error, right? So then you find out the magnitude and then divide it by 2. Okay, Smera, did you understand the concept?
Yes, sir.
Okay, all right. All right, and all of you please write it down. Sheldon, got the concept?
Yes, sir.
Good. Okay, so please write this down and let me know when all of you are done. All right. Okay, Sheldon, are you done?
Yes, sir. Done writing.
All right. So all of you will have to stop our class at this point. See, the reason being the entire vectors portion in your books has been divided into 2 chapters. At this point, we have finished the first chapter. And then the second chapter or the second sub chapter in vectors is on the 3D lines and all the planes, all that kind of 3D vector notations we'll cover there. So I don't want to start that concept right now because then we'll have to revise it all over again in the next class. So we'll start for the 3D vectors right from the beginning from the next class. Is that fine?
Yes, sir. Sure.
Okay. So all of you, so the next class will be on Saturday, same time, 6 p.m. All right. So if you have any doubts, please WhatsApp. All right. So take care. Bye bye, all of you.
Thank you, sir. Bye, sir.
Bye, sir. Thank you, sir.
Bye, sir.